Hello, everybody, and welcome back to another Mr. Farney Earth Science video. We are here. We have finally made it to the meteorology unit, wherein we're going to focus on two specific sections. We're going to start with the atmosphere. We're going to learn about its components. And then after our atmosphere section, we're going to move on to weather forecasting. So let's go ahead, dive right into the atmosphere. In this video, we're going to focus on just atmosphere basics, what makes it up, and then talk a little bit about the different layers of the atmosphere and some components of those different layers to pay attention to. So firstly, what's the big idea of this section? We're looking at the composition, structure, and the properties of Earth's atmosphere that form the basis of our weather and our climate of our biosphere. So energy is transferred throughout the Earth's atmosphere. That's the main idea of our basic understanding of this section. Energy is being transferred. How is it being transferred? What does that transfer of energy do to kind of drive all the other components? We can't understand how energy is driven without understanding what makes up the atmosphere. And our atmosphere is 78% nitrogen. That's a lot of nitrogen. But you're saying, Mr. Farney, I breathe oxygen. I don't breathe, nitrogen. Well, this is true. And if you remember back to our discussion on geologic history, are cyanobacteria that make up a large component of the early ocean that produced enough oxygen for multicellular life to form, but it didn't take too much. That's why, our 21% of Earth's atmosphere that's made out of oxygen is enough to help us sustain life here on the planet. So 78% nitrogen, 21% oxygen. And then that last one remaining percent is a whole bunch of different trace elements. Very, very small amounts like carbon dioxide, water vapor, dust particles, and then ozone, which we'll get to in a minute. But you might say, Mr. Farney, I've heard this thing called climate change, and they're always so argumentative over carbon dioxide and how that's affecting Earth's climate, how it's affecting the intensity of our greenhouse effect. If it's only part of this 1%, does it really make a difference? And the answer is yeah. Since it's in the atmosphere in such small amounts, any amount of changes to that specific molecule in the atmosphere can lead to kind of large, widespread impacts globally. We're not going to get into it too much in our weather section here, but when we come back to this, when we get into talking about specifically the climate in a few months, we'll see more why this is more important there. In this section, we'll focus more on ozone and how that's important in our atmosphere and what that does for us. Now, the highest concentration of ozone is found in the stratosphere. And you might have heard this term. That part of the stratosphere is called the ozone layer, and it acts like kind of like a natural suntan lotion for our planet. It occurs naturally in our environment. So, ozone is not necessarily a bad thing if it's occurring naturally, but if it is man-made kind of ground level ozone that can happen sometimes in a lot of industrial cities, that's not very good for us. We don't do very well inhaling ozone or being exposed to ozone. But back to that suntan lotion analogy, ultraviolet radiation from the sun comes in 3 different wavelengths. You have UVA, UVB, and UVC light. All of them are very detrimental to us as organisms on the surface of the planet. But the higher the frequency, the shorter the wavelength of light, like our UVC, that would do a lot of damage to, those of us with an epidermis. So thankfully, the ozone layer does a really good job blocking all of that UVC light. If you look at a regular suntan lotion bottle, you might notice it says UVA, UVB protection. It's the ultraviolet radiation that is kind of able to kind of skip through the ozone layer, making it to the surface. So the ozone layer as a whole does a very good job blocking out that very harmful ultraviolet radiation. But then humans come into play. We come up with some technologies in the late 60s, early 70s, like air conditioning. We have different aerosol cans, and they're all kind of able to do these types of technology things because of this one chemical we came up with called CFCs, or chlorofluorocarbons. They're used for refrigerants, aerosol cans, anything that goes contained a CFC in the past. Mainly what allowed it to do that noise was chlorine. It's the release of these aerosols and release of that chlorine in the atmosphere that destroyed a large component of the ozone layer, giving us the hole that we see in many kind of very famous pictures of the ozone layer. As you kind of work through this section, you'll probably come across one of these pictures in some way, shape, or form. One chlorine molecule can actually destroy thousands of ozone compounds. So it is very, very detrimental to our ozone layer, even in small amounts. Now, let's talk about the 5 different layers of the atmosphere. And scientists break up the different layers based on their composition and based on their temperature gradients as you move up through them. And you'll notice that as we kind of go up through the atmosphere, they're going to do this kind of zigzag wiggle pattern as far as temperature goes. So our first layer, it's the one we live in. It's the troposphere. It's closest to the surface. It is where all the weather happens. As you go up in elevation, temperature is going to decrease. At the very, very top of the layer is where, airplanes fly 30, 40,000 feet at the top of this layer, right above the clouds. That is where airplanes fly. So troposphere, closest to the surface, weather happens here. Next, we get the stratosphere, which is the home to our ozone layer. Again, ozone protects us from the sun. It protects us from that UV radiation that comes from the sun. And again, like I said earlier, 1 atom of chlorine from CFCs can destroy thousands of ozone molecules. As you go up through the stratosphere, you're actually going to increase in temperature because the ozone layer is going to absorb radiation from the sun, keeping that part of our atmosphere a little bit warmer. So stratosphere, layer 2. Above the stratosphere, we get to the mesosphere. All you really need to know about the mesosphere right now, it's the 3rd layer. Temperature decreases as you go up through elevation. Following that is the thermosphere. We're running out of oxygen here in the thermosphere. Temperature is going to increase a little bit. This is where space shuttles orbit in this layer. Possibly why they chose this layer is because temperature is increasing. So, it's a little warmer. It's a little probably easier to sustain some of that technology that's orbiting around the planet. And it contains our ionosphere or charged particles. So the thermosphere is the sphere or the layer of the atmosphere that generates like the auroras because of those charged particles. When, solar storms hit the planet, those charged particles do their thing and we get very pretty images like the one seen here in this picture. The last sphere or the last layer is the exosphere. This is the one we're going to care about. This is the last bit of Earth's atmosphere right before we get to space. And this is also the layer of the atmosphere that contains our satellites. So again, let's review them real quick. Troposphere, stratosphere, mesosphere, thermosphere, exosphere. Those 5 layers make up our entire atmosphere. It's going to be very important. You're going to be able to kind of differentiate and break down the difference between them. Lastly, each of these layers has a boundary between them. And we use the word pause to indicate that boundary. So tropopause means you go all the way up through the troposphere and then you pause at the top. And then you enter the stratosphere. And you go all the way through the stratosphere and you pause at the top. Then you go through all the way through the mesosphere, pause at the top. We kind of follow here. You might ask yourself, Mr. Farney, why is there no exopause? It's because that's the last one. The exosphere is our last sphere. So there is no exopause between the top of the exosphere and space. It's just, you're now in space. So that's why we have no exopause. This is a very nice picture. Shows a couple little bit more bits of information. One of the things here that I want to point out that, weren't in the slide specifically is here in the mesosphere. That's where we can get shooting stars and the burning up of other kind of space debris in our atmosphere. That's the layer of the atmosphere that kind of causes that for us. Very cool. You can also see the ozone layer there, picture of a satellite, and then the altitude here on the right is in kilometers. So you can see how very high this whole kind of structure of our atmosphere actually is. So that's all I'm going to talk about in this video. Come back in the next video where we're going to discuss energy transfer, the 3 different types, and how that kind of plays into the overall discussion that we're getting to. So thank you very much for paying attention. Ask me any questions if you have them. If not, have a good rest of your day. and we'll see you next time. Bye-bye.